Hey guys, what is up? Welcome back. We have got an interesting video today. Actually, we have a question that came up in a calculus class of mine. We were doing calculus class, calculus 3, and we were talking about projectile motion. And we were just asking some different questions of like, what is the furthest distance that this projectile could go in a horizontal way? What is the furthest distance it could go vertically? What is the optimum angle to shoot it at to maximize the range, the horizontal distance? What is the time that it travels in the air? Stuff like that. And then this one question came up. This one question was, what angle equalizes the horizontal range and the vertical distance that the projectile will travel? And that was an interesting question. So basically we want to know, what is the angle theta, we'll call it theta here, what angle theta will optimize, or sorry, not optimize, but equalize this horizontal range. So this is the x distance that the projectile travels, and this vertical range, it's the y distance, or the maximum y value from 0 that this projectile will travel. So that was the question that we asked, and then we tried to answer that question, and I want to go over the answer to that question because it was pretty interesting. So the range, let's talk about that range equation. The range equation was x equals v0 squared sine of 2 theta over g. And the y max, the vertical distance, the maximum vertical value, was given as v0 squared sine squared theta over 2 times g, where g is a gravitational constant. Theta is the angle you launch at, and v0 is the initial speed you give the projectile when you launch it. Now, you can go back and check out how we derive these. I have a lecture where I actually go through this from being online last year, and you can check that out, actually, how I get these equations. But assuming we start with these equations, we want to know, how do we find the angle theta that we need to launch at to basically to make these the same, the x distance x and the y distance y max. We want those to be the same in this case. So what we need to do is just equate these two. So we just equate the x and the y value. So equate these two equations, these two. And if we do that, we also actually want to remember a trig identity in that sine of 2 theta is equal to 2 sine theta cosine theta. And if we use that identity right here, the sine of 2 theta equals 2 sine theta cosine theta, and then set them equal, we get 2 v0 squared sine theta cosine theta over g equals, so that's the x value, equals v0 squared sine squared theta over 2g. And what we can do at this point is cancel the v0 squared. That's in the numerator on both sides. We can cancel the g because that's in the denominator on both sides. I can cancel one of the sine thetas with this square here, and that'll leave us with an equation. The equation that it leaves us with is 2 cosine theta equals 1/2 times sine of theta. And at this point, we can basically multiply both sides by 2 to get rid of the 1/2 and divide both sides by cosine. So if we do that, we'll get 4 equals sine over cosine, which is tangent. So 4 equals tan theta. And if we solve for theta, just take the arctangent. We get theta equals arctan of 4, which turns out to be about 76 degrees. So the angle that we have to launch the projectile at to make the range and the vertical distance the same, the horizontal range and the vertical distance the same, is about 76 degrees. And when we do that, we'll get this picture right here. We get for whatever initial velocity it is, we get a parabola whose horizontal intercepts, the x-intercepts, are the same as this distance from the x-axis to the peak of the parabola. So it's really an interesting problem. This question could be easily modified to ask something like, what is the angle needed to make the range twice the distance of the vertical distance traveled? Or what's the angle needed to make the horizontal range half of the vertical distance traveled? All kind of slight modifications you could make, but the process would be very, very similar. Only the numbers would really change. So it's a good problem. I enjoyed doing it. I enjoyed thinking about it. Thought you guys would enjoy checking it out too. So that's how we do it.